So here we have question 6 of the Edexcel International paper. It's a statics question, and it's about something being resting on a smooth peg here at C, and there's friction at A, so there's going to be a force, a reactional force, a perpendicular reaction force there, and there's going to be a frictional force here. Because later on in the question it talks about the coefficient of friction, and it doesn't say it's in limiting equilibrium at any point. I'm not going to mark mu r on our diagram. I suspect it's going to come in to our last part of our question, where we're going to use the inequality f is less than or equal to mu r to get that result. Right, okay, so first question, a 1 mark question, which they come up, a modelling type question, which are a little bit less frequent than they used to be, but do come up. It says, give a reason why the force acting on the rod is perpendicular. Notice it talks about the force. It doesn't talk about the reactional force. It means the force. And what that's meaning there is basically the combination of the reactional and frictional component of the force. And the reason there's no friction, of course, is because the peg is smooth. So that's the answer there. That's what they're looking for. Yeah, it's in the word in a second. It talks about the force, so that means the force is perpendicular. If it is perpendicular, that means that there cannot be any frictional component of the force, overall force acting at C. Okay, so the magnitude of the force acting on the rod is this, is what we're asking to show now. So, got a bit of information here. We're also told it's uniform. It's of length 4a, so there's going to be a weight here, and the weight is W. And the angle they're saying is alpha. That means that angle here is alpha. Apologies about the small diagram. And the angle here is alpha, as it was marked on the original diagram in the question. Okay. Now, there is also another, if we read the thing in its entirety, I think it talks about a weight of kW acting at B. So the first thing is to find the magnitude of the force, and it's the reaction force. Let's call it, if we call this one RA and call this one RC, that reaction force. If we take moments about A, we're only going to get 3 forces in the diagram. KW, which is that angle there, W and RC. So that's going to get us in one equation that result, if we're careful. We need to take care with our angle. We've got tan alpha equals 1/3. I'm not inclined to use a calculator here again. This is fairly routine stuff. If we use Pythagoras there, we can see that's the square root of 10. It's kind of encouraging because the square root of 10 comes into our answer. So there we go. It's amazing how these things fit together. So if you kind of go think about things carefully and systematically. So that means that sine alpha equals to 1 over the square root of 10, and cos alpha is 3 over the square root of 10. Right, so that's going to help us in a moment. Now, so we're doing part B now. If we take moments about the point A, as I said. Right, now, the component of the let's work out the R bit, because that's the bit that's going anti-clockwise. That's just RC times 3A. Okay, because that length is 3A. That length here is 3A. Now, what I tend to do is actually, maybe need a different colour here. look at the component, this component of that force and this component of that force. Now this component here is W cos alpha, and this is KW cos alpha. The bit that's going parallel to the slope will of course have no turning effect on the force. So going back to the red, right, so we've got the turning force of the weight, that's the actual rod, that's at a distance 2a from here, but the component is W cos alpha. So we can write W cos alpha times 2a plus KW cos alpha, that's this one here, times 4a. Okay, quite a bit, obviously a cancels. Okay, and we should be able also to substitute in our values of cos alpha here. So we have 3RC equals to 2W cos alpha, and cos alpha is 3 the square root of 10. Okay, plus KW cos alpha, which is 3 the square root of 10 times 4. Okay, now 3 cancels. Okay, so I can see if I factorise this with the square root of 10 on the bottom initially, I can see I've got RC is equal to 2W over the square root of 10. And now here, that's the whole of this bit here, the whole of the bit here is that. So that's 1 plus, and there will be a 2k left here. Now that's not quite the set of what we've been asked to show, but we can see that I'm sure that anyone who's marking this is going to be convinced that you know what you're doing. Times it by square root of 10 on top and bottom here. Rationalising the denominator to the third, can easily be seen that that's the square root of 10 W over 5 1 plus 2k as required. Okay, so that's part B of the question done relatively easily. Now it talks about the coefficient of friction at the point here. Now this is all to do with F and RA. We're obviously going to need to work out F and RA to be able to answer this question. Okay, so so then we'll be able to use F is less than or equal to mu r. I'm going to resolve horizontally and vertically here rather than take moments. Classically, I don't want to really be too formulaic about this, but classically these questions involve doing 3 equations, and normally a resolve vertically, a resolve horizontally, and a moments equation. But that's perhaps a little bit formulaic, but they do tend to fall into that. We'll resolve horizontally first of all, and that's going to enable me to work out the friction in terms of W, because I've got F. There's only 2 forces. We've got this RC going. We've got the RC force, and we've got the frictional force horizontally, and that is it. So we've got F equals RC sine alpha, and that gives us F is equal to, we know that sine alpha is 1 over the square root of 2, and we know that RC is the square root of 10 W over 5 1 plus 2k, and we know that sine alpha, as I've just said, is equal to 1 over the square root of 10. You can see the square root of 10 cancels, so we're left with F equals to W over 5 1 plus 2k. Okay, so there we go. That's going to be handy in a sec. That's because we've got F. Now if we resolve vertically, we're going to get RA in terms of W, because we know RC. We've got RC here, so we're going to get RA, and then we can use the coefficient of friction inequality. F is less than or equal to mu r to get the required K is less than or equal to 2/11. So if we resolve vertically, we can see we've got RA going upwards plus RC cos alpha going upwards. Downwards, we've got W and a KW. Okay, now let's just put this in here. RA plus RC, which we know from above, square root of 10 over 5 W, 1 plus 2K. Cos alpha, which we've also got written above there as well, 3 over square root of 10, is equal to W plus KW. Again, the square root of 10 is cancelling. Okay, and if I play around with this a bit, let's not rush it too much. So we've got, if I play around with this and multiply it out, it's probably the best thing to do. So because we've got W's in everything and we've got W, so I'm going to do that. RA plus W, when I multiply this out, I'm going to get W over 5 plus 2KW over 5. Oh, I'm times them by 3 as well, so I've got 3W over 5, and I've got 6KW over 5 there when I've multiplied those bits out. And I've still got a KW, a W plus a KW. And when I rearrange that, I'm going to bring over to the other side. I'm going to get RA is equal to 2W over 5, because we've got W minus 3W over 5. Then 2W over 5, and then for the KW it's going to be minus KW over 5. Let's write that in factorised form. W over 5, 2 minus K. Okay, so we've got RA. So we're getting there, because we need to show that we've got F is less than or equal to mu r. That's our inequality that defines friction. So we've got our F is here, W over 5, 1 plus 2K. It's got to be less than or equal to mu, and we are told mu. I haven't mentioned that yet, but mu is something that's actually been given in the question somewhere. There we go, later on, 3/4. And R, which is W over 5, 2 minus K. Right, I'm going to cancel the 5 and then probably just multiply out, and W obviously cancels as well. Multiply out, we can multiply by positives with an inequality, no problem. So we're going to get 4 plus 8K is less than or equal to 6 minus 3K. That gives me 11K is less than or equal to 2. So K is less than or equal to 2 over 11 as required. Another question that I quite like, because again, as has been the case in lots of the questions on this paper, I've not used a calculator. Thank you very much.